Welcome to the Oprah Show. I'm Oprah. This week, we have two scientists who isolated protein, more specifically myoglobin, from ahi tuna. Myoglobin facilitates oxygen diffusion within muscle cells. The first part of the experiment involved turning 1 gram of muscle tissue into fine powder with liquid nitrogen and a mortar and a pestle. The powder was then transferred to a 15 milliliter centrifuge tube. 6 mils of ice-cold extraction buffer was then added, which included tris, NaCl, EDTA, DTT, and PMSF. The sample was then shaken for 2 minutes with it kept cold by immersing it in ice. The material was then centrifuged for 10 minutes at 4 degrees Celsius in order to remove matter. Supernatant was then transferred to a 15 ml tube and placed on ice. This is known as the crude myoglobin extract. 500 microliters of supernatant was then placed into a 1.5 ml screw cap tube and put into a freezer. Next on the show, introducing the second part of the experiment, is my dearest friend, Laura Miranda!
Hi Oprah, nice to see you
Hello,
again.
Laura.
So I will be introducing size exclusion chromatography, which separates molecules of a solution based off their size. Larger molecules go through a side route where smaller ones are forced through the pores made up of cross-linked polymer beads. A column is prepared with extraction buffer kept at a certain level. We pipetted 0.5 milliliters of crude myoglobin extract and collected 50 samples of 10 drops each. The samples were ran on a nanodrop spectrophotometer to measure the myoglobin levels at 280 and 418 nanometers. 280 is where aromatic rings of tryptophan and tyrosine peak and tells us the concentration of protein in the sample because one absorbance equals 1 milligram per milliliter of protein. As you can see in this table, we found that the highest concentration of myoglobin was 0.021 milligrams per milliliter.
Next, we're going to have another scientist talk about the second method of protein extraction that was used in this experiment. Please welcome my dearest scientist friend, Angela French!
Hello.
Hello, Angela.
Hi, Oprah.
So can you please explain the second method you guys did for protein extraction? I think it's called ammonium sulfate precipitation.
Yeah, we commonly use ammonium sulfate in order to precipitate out. We call this salting out. And basically this works because the solubility of a protein is lowered in the presence of some salts. So the process in which salting out works is that as you add ammonium sulfate, which is a salt, it goes in and a hydration shell or water goes around the ions, causing it to be more or less distracted from the proteins, and so the proteins come out while the water is busy surrounding the ions. We basically added about 4 different concentrations of ammonium sulfate, one at 30%, one at 45%, one at 60%, and one at 75%. We took 5 milliliters of the crude myoglobin, added the specified amount, let it chill for about 10 minutes in ice, and then centrifuged so that the proteins were at the bottom. And then after that, we would decant or pour out the liquid.
The second part of the experiment uses polyacrylamide gel electrophoresis on the protein samples extracted from size exclusion chromatography and ammonium sulfate precipitation. We added 500 microliters of suspension buffer and 5 microliters of 20% SDS, sodium dodecyl sulfate, to the ammonium sulfate pellets. The resuspended pellets were then vortexed and boiled for 5 minutes, then set to cool. 100 microliters of 4 samples from our choice from the SE chromatography were added with 1 microliter of SDS each. These samples were then boiled for 5 minutes and set to cool. 5 microliters of loading buffer containing glycerol and dye were added. Crude myoglobin was used to create a sample in the same manner. Gel electrophoresis was then used on all the samples. SDS, the fluid that submerged the gel, works by disrupting non-covalent bonds in the proteins, denaturing and created charges. Electrophoresis allows proteins to be visualized as well as separated. The negative charge samples caused by the SDS move downward because the bottom of the gel is positive. The gel made up of polyacrylamide gel acts as a molecular sieve, slowing the migration of proteins by size. We noted which wells contained which samples. Samples were then electrosphered for 30 to 40 minutes at 180 volts, or until the dye migrated 1/2 or 2/3 of the gel. The protein was then stained with e-stain instruments, which uses staining pads with Kumasi blue dye and proprietary electrode buffers. The voltage is applied, driving the negatively charged Kumasi blue dye reagents into the gel matrix between the pads to stain the proteins, all in 7 minutes. The gel showed that myoglobin was present in all samples taken because the individual bands matched the crude myoglobin extract band.
Now that we're done with the show, everyone check under their chairs, 'cause free ahi tuna for everyone!